Hello friends, welcome back to Civil Engineering Mastery. In this video, let's discuss how do we model and analyze G+2 commercial cum residential building in Etabs software with lateral loads. Lateral load includes wind load and earthquake load. So without further delay, let's begin. To start with, let me explain you with the floor plan. This is the ground floor plan. Here we have parking area, shops, office and one unit of residential building. And in the first floor, we'll be having 2 units of residential unit. And in the second floor also, we are having the same thing, 2 units of residential building and we'll be having staircase headroom. So this is the floor plan. Now let's see the section. So from natural ground level, we have 6 feet excavation depth and after that we'll be having 1 feet 6 inch. That is our plinth level, and after that also 1 feet 6 inch is the height of ground floor level. So in the parking area will be 1 feet 6 inch down when compared to the ground floor level. So from ground floor level we have 10 feet as a roof height, that is first floor level, and from first floor level we have second floor level of 10 feet height, and again we'll be having 10 feet height of third floor level. So this is the section. Let's modeling the same in the Etabs software. Let's start modeling. Go to edit and edit stories and grid system. So here modify and show grid system. Let's enter the values as per the architectural drawing. So here display grid as spacing. So this is the x direction values, horizontal values. So first column to column distance is 10 feet 9 inches. So first let's add few grids. We have A to H. So let me going to add G, H and one more. Here I'll give 10 feet 9 inches and again 10 feet 9 inches. So I have entered all the values in the horizontal direction till this one, till H grid. Next let's enter the values here in Y direction. So here we have 16 feet 9 inches, 10 feet 9 inches. Only 3 grids we have to enter in the opposite direction actually. So here it is 10 feet 9 inches and 16 feet 9 inches. That's all. This we can delete. Give OK. 7 spacing, and here also it is 1, 2, 3. We have got the grid now. Next what we have to do, we have to enter the story values. For that again go to edit story data and modify story data. So in this one let it be base. Next one is plinth. Plinth is 6 feet plus 1.5 feet. Height is the plinth level, so that we need to consider. So it will become 7 feet 6 inches. And the next one is ground floor roof. That will become 11 feet 6 inches. Because ground floor level to first floor level it is 10 feet, and below that we have 1.5 feet extra from the plinth top level. So that is why here I am considering 11 feet 6 inches. Next one is first floor roof. That is just 10 feet only, and second floor roof, that is also 10 feet height only. Let's add the headroom, add story, keep existing story height, give OK. So this one let's mention it as headroom, which is of 8 feet height. So that's all. Let's give here the similar to none. So ground floor and first floor we can take as a similar stories. This one is similar to, this is not a master story. So let's make this one as master story, and here we can make this one as similar story. Ground floor roof and first floor roof are similar. Second floor roof is also same. This is the framing plan. So the ground floor framing plan will holds good for all the 3 floors. First floor roof as well as second floor roof. The same we are going to continue. So that is why I told all the floors are similar. That's why I made in Etabs as a similar stories. Just let's look into the beam size and column size. We have beam size of 9 by 15 inches and 9 by 18 inches. 2 beam depth we have, beam sizes we have, and column size this is 9 by 12 inches, and this one is 9 by 15 inches, and we have 9 by 9 inch column as well, and we have the cantilever slab all around this area. This area is 2 feet cantilever, and here it is 4.5 feet cantilever we have. Next let's define the section properties. Go to section properties and frame section. So here let's add the new property concrete. First let's add the column sizes to 25 by 375. Select the grade as M20, and here let's give this 375 and width as 225, and modify show rebar. here let's choose the reinforcement bar, and column cover is 40 mm. And this one let's keep it as 16 mm. And confinement bar let's choose 8 mm. Give OK. And again give new property, concrete, column 225 by 300, grade M20, here 300, here 225 as width, and again modify show rebar as 16, 500 you can choose, and the confinement bars 8 mm you can choose, and again give OK. Again we can add another column property, C 225 by 225, M20, 225, 225, and here let's choose HYSD bar 500, and let's choose the bar as 16 mm and here 8 mm. Now we are done with the column property. Next let's add the new property for beams. Beams we have two sizes. One is 225 by 375. Choose the concrete grade as M20 and 375 225. Here choose the beam design and again grade of steel. Give OK. Next one is gain beam. Add beam 225 by 450. Here 450 225. Modify and show rebar. OK. Slab section we need to add. Go to section properties. Slab section. Let's add new property. Yes, 125 5-inch thick we are going to consider. And here let's let it be shell thin. Let's change the thickness. Give OK. So we are done with the properties. Let's start drawing the column. For that first we have to select here as all stories. Let's take the AutoCAD plan as well. Select this quick draw command, and here let's select the C225 by 375 columns. So we have here vertical column and here one vertical column. So let's place in the C grid, that is 90-degree angle in this area, and then let's change the orientation. Next let's choose the other column, that is 225 by 300. So 90-degree we have one column here, one column here, and then one column here, and here we have one column, here we have one column, and then let's change the orientation and place it here, this place, here in this place. This is 10 feet 6 inches. Copy this column and paste. Next let's take the square column. We have done with the columns. All the columns are drawn, so you have to keep this one active, all stories. Let's see in the plan view. So in headroom also we have all the columns, so we don't want these columns in headroom, so only here you have to keep one story and then you can delete. Now delete, so then only the headroom columns will be projected in the headroom plan. Now let's go to plinth level and then add beams. This is the plinth beam layout. This is very important. Plinth beams are used to connect the columns in both directions, and this is reducing the height of the column. So if you want to know more details about plinth beam, I have already posted one video, detailed video about plinth beam, what is the use of plinth beam. So please do watch that video if you want. Here you have to keep it as one story. Let's go to quick draw beams. This is the quick draw beams option. So here you have to select the beam 225 by 375. And if you see in the first area, it is 9 inch by 15 inch only. So this is 9 inch by 15 inch, and these all 9 inch by 15 inch. Again here also similar beam setup will come, and this last beam also 9 inch by 15 inches. So let's add like this. Next what we have to do here, if you see this span is more, so let's keep it as 18 inches. This is 18 inches, this is 18 inches, and again this one we can keep it as 15 inches only. This is 15 inches, and let's choose 18 inches. This is 18 inches. This one is 18 inches. This is 18 inches. Here also it is 18 inches. So in the middle we need to add one beam as 18 inches. This distance is 4 feet 9 inches. At 4 feet 9 inches we have one beam. Control C, Control V. This is 0, and here it is 4 feet 9 inches. Give OK. So we have one beam, and here we have one beam. Let's check this dimension. This is also 4 feet 9 inch only. Minus 4 feet 9 inches. Give OK. And in between here we have one beam. 6 feet 3 inches. So this one we can copy and paste. 6 feet 3 inches. Give OK. So now the plinth beam layout is ready. Next let's add the beams in the ground floor roof. Now let's choose similar stories here so that whatever the beams we draw here, that will be replicated to all other similar stories as well. So let's choose the quick draw beam option again, and let's check whether the beam depths are same or not. All the horizontal beams are of same depth. Only here we have 18-inch beam depth. These are all 15 inches, and again down also if you see here only this is 18 inches, rest all 15 inches only. Next let's choose the 18-inch beam depth. This is 18 inches, this one is 18 inches, and here we have one 18-inch, this is 18 inches, this is 18 inches, this 18 inches, this one is 18 inches. And let's measure this one, how much distance we have this beam, 6 feet. Before that let's measure this one, at what distance we have beam over here is 8 feet 10 inches. So this one let's copy in the x direction, 8 feet 10 inches. Now this one we can divide it. Divide 0. The y direction it is 6 feet. And this one let's see 4 feet 4.5 inches. So let's divide this 4 feet 4.5 inches. 4 feet 4.5 inches. So this format we made, and here let's add few beams. 6 feet 3 inches. Give OK. So we have beams here, and again let's add this one. From here it is 4 feet 10 inches. 4 feet 10 inches. Give OK. Here we have one beam of 15 inches. So let's select this one by connecting these two columns. We have one beam in between. So let's first add this Sankhya beam, 4 feet 9 inches. 4 feet 9 inches. We are done with the beams. So let's add 3D view as well, and then check whether it has been done for all the floors or not. See, beams has been drawn for all the floors. Next let's add the slab. Quick draw floor or wall, that option. Here select slab 125, and then here also you have to choose similar stories. So you can just click on adding the slabs, and then later on you can merge or divide the slabs. If it is like this, here you don't get slab because it is a staircase area, and this one select these beams and then divide the slabs. Divide shell. So select first one, cookie cut floor objects with selected frame object, give apply hook. You see here, see it has been divided. Now what you have to do, these two things you have to merge. Give OK. See, this is single slab now, and again these things you have to, so this is not divided actually. Divide frames. Now these two things you can merge, and these two things you can merge. This one you can just divide, merge. So like this you can do for all the slabs. See, I have merged all the slabs according to the framing plan. Now let's add the cantilever projection. So here we have 4 feet 9 inches cantilever this side. So let's copy this B, Control C, Control V. In the X direction it is minus 4 feet 9 inches. Give OK. Control C, Control V. The Y direction is minus 4 feet 9 inches. Control C, Control V. The Y direction is 4 feet 9 inches. So we have got the projection, and again this side we have 2 feet projection. 0 is minus 0.6. We have got the projection, and we need to join these two things. Let's draw one beam line which is of none property. We can delete this. Sorry, only we can delete this, and then now we can add one beam. So whatever the beam we are taking here, it should be of null property. So select this one, and then here choose the property as none. Give OK. Here also you can connect the null property, because this is the cantilever projection. We don't require any beam property over there. So this one also we can change it to none. And again let's go with the, so the projection is still here from this column. So let's copy paste this one. The y direction minus 0.6. OK, and add one beam here with the null property, and again let's add one beam here. That's all. Now let's fill the slab. So let's select this one and then choose the property as S125. So like this you can draw the slab. So it is done actually. The model is ready now. Let's check with the 3D view. only headroom slab we need to add. So for that, let's go to plan, headroom, apply, okay. And here let's change it to 1 story. First we need to add the beams, withdraw beams. We have the beam now. Now let's add the slab. This is also done. Next we need to apply the load. So before that, let's have a look into the loading detail. First one is dead load. In dead load we will be having self weight of the slab, that is thickness multiplied by unit weight. So we get 3.125. Main wall load is 13.5 kilonewton per meter. Partition wall load is 6 kilonewton per meter. Floor finish load is 1 kilonewton per meter square. And parapet wall load we have 4.5 kilonewton per meter. Live load is 2 kilonewton per meter square. Staircase load we have, this is the landing and this is the going area. So we have RA 18.41 kilonewton, that is the landing side, and going side we have 23.75 kilonewton, mid landing level and the roof level. And cantilever slab, here I have calculated cantilever slab load on beam. So we have already drawn the cantilever slab. So on that we can directly apply the slab load, that is self weight and floor finish and live load. Next one is sunk slab load. Sunk thickness multiplied by unit weight of filling material. Sunk thickness is 10 inches. Cinder filling material is 8 kilonewton per meter cube. So we get 2 kilonewton per meter square. So let's apply all these loads in the model. Before applying the load, let's define the load. Go to load pattern, and here dead load is the self weight. So let it be the same. And next let's add the main wall load. Main wall load, that we have to keep it under super dead load. Add new load, and then partition wall load, add new load, that is also super dead. And here the self weight multiplier should be 0. Only for the dead weight it should be 1. Next one is floor finish, add new load, and sunk load. Sunk load also we can add. And staircase load, so that one we can write it as mid landing beam. I'm adding this one. And next one is roof stair. Roof stair, add. That's all about this super dead load. Live load is already added. And next we need to define the wind load and earthquake load. So first I'm going to add EQX, earthquake in X direction. So here self weight multiplier is 0, but in this type we need to select seismic. And auto lateral load, here we need to select the code as IS 1893 2016. Give add new load, and again in the Y direction the same thing we need to give add. Similarly, wind X direction, add new load. Sorry, here you have to select the wind load, modify, and here you have to select the code as IS 875 2015, modify. Next let's give wind in Y direction, again the same thing, add new load. So we have defined all the load cases. So let's assign one by one. First I'm in the plinth area. So what I'm going to add is, in the plinth area we'll be having wall loads. So all the outer walls will be having the main wall load. In this area we have only parking, so we don't get wall load. So go to assign, frame loads, distributor, and here you have to select main wall load. So give the value as 13.5 kilonewton per meter. Give apply, okay. So plinth beam load is applied. Next what we have to do, we have to go to ground floor roof. Next let's select all the ground floor roof outer beams. So that's all. Main wall load will come on the outer beams, and then this staircase area, and here also the main wall load will come. Go to assign, frame loads, distributed. So let's give apply, okay. So it is applied. Next, partition wall loads will come on this area, this sunk area, this one, and this one. Here also partition wall load will come on the selected beams. So let's go to assign, frame load, distributor, and give 6 kilonewton per meter as a partition wall load. Apply, okay. Next let's apply the floor loads. Select all the slabs. So floor finish load will come. Let's select this cantilever slab as well. Anyway, self weight is going to come. And after that, go to assign, shell load, give uniform, and here give floor finish. Floor finish we took as 1 kilonewton per meter square. Give apply, okay. And next give previous selection and go to assign, shell loads uniform, and then live load as 2. Give apply, okay. And next, sunk area. So we have the sunken portions 1, 2, 3, 4. These 4 areas we have sunk, so that we need to apply the sunk load as 2 kilonewton per meter square. Go to assign frame loads distributed. Go to assign shell load uniform, and then select this sunk load 2 kilonewton per meter square. Give apply, okay. So we have assigned all the loads, beam load and slab load. Next, let's go to the first floor roof. So here we need to select all the outer beams again, and again go to assign frame loads distributed. Select main wall load 13.5 kilonewton per meter. Apply, okay. And next, select these walls for partition wall load. Go to assign frame loads 6. Apply, okay. That is done. Next, select all the slabs. Go to assign shell load uniform. Select floor finish load. Give 1 kilonewton per meter square. Give apply, okay. And again, previous selection. Go to assign shell loads uniform. Live load you can add 2 kilonewton per meter square. And next, sunk load you can add for these 4 slabs. Go to assign shell load uniform. Select this sunk load. Give apply, okay. Next, let's go to second floor roof. So here what happened, the main wall load will not come, because since this is the top floor, we'll be having the parapet wall load of 4.5 kilonewton per meter. Let's see whether we have defined the parapet wall load or not. So it is not yet defined. So let's define that one. Parapet wall, add a super dead load only, and give add new load. Yes, it is added now. Now let's select the all around beams, and then add that parapet wall load as 4.5 kilonewton per meter. Apply, okay. And the sunk load also will not come, since this is the top load. So let's select all the slabs and then apply the load. Live load and floor finish we can apply. So go to assign shell load uniform. Live load is 2. Floor finish as 1. Give apply, okay. Next, go to the headroom plan. So here there will not be any loads on the beam, only slab load will come. So go to assign shell load uniform. Floor finish we can add. Live load we can add. Next, let's apply the staircase load. So for that we need to add the mid landing level beam. So here I have selected the second floor roof, that is third floor level. So that beam I have selected here. You can see it is selected here. So from the 3D view, what we can do, Control C, Control V. Here you can give 0, and from here it is minus 1.5, because 3 meter is the floor height. So 1.5 meter level I have provided one mid landing beam. So select that one, and then go to assign frame load distributed. Here you have to select the mid landing beam. It is 18.4 is the load. Give apply, okay. So it is assigned. Now again what you can do, just Control C, Control V, give okay. Now again you have to assign the load. Give apply, okay. Next, select this one, and again it has to go to the first floor roof mid landing level. From below first floor roof it has to go. So select this one, and then Control C, Control V. Here it is 3 meter. At 3 meter level it will come, and again select this one. Control C, Control V, 3 meter. Now select this one, go to assign frame load distributed, the same you can assign, and again select this one, go to assign frame load distributed, apply, okay. Next, at roof level you have to assign the roof level staircase load. So for that we have to select this beam, and then go to assign frame load distributed. So that is roof stair 23.75. The load is 23.7 kilonewton per meter. Apply, okay. We are in second floor roof now. Next, let's go to first floor roof. Select this beam. Go to assign frame load distributed. Apply, okay. And similarly, we have to go to ground floor roof. Give assign, apply, okay. See, we have done with the gravity load. Now we are done with the gravity load. Next, let's apply the lateral load. First, let's see the IS 1893 code for the zone. The building is located in Ahmedabad, which is zone 3. The value is zone factor value is 0.16. Importance factor is 1 because we have all other buildings, because it is a residential cum commercial building, not occupancy more than 200%. If it is more than 200% means we have to consider 1.2. It comes under all other buildings, so we need to consider the importance factor as 1. Next one is response reduction factor. So this one we have to consider as second one. RC buildings with special moment resisting frame, we need to consider the response reduction factor value as 5. Let's go to define load pattern. So here what we have to do, select this EQX, modify lateral load, and it is in X direction, only consider X direction, and top story is headroom, bottom one is plinth level. Top story is headroom and bottom story is plinth level. Response reduction factor, as I told you before, it is 5, and seismic zone it is 0.16. Zone 3, it comes under zone 3, so it is 0.16, and soil type is 2 medium soil. Importance factor, as I told you, it is 1, and time period we can give it as program calculated and give. So this is how you have to define the earthquake loads. And next, the y direction as well you have to do. So uncheck all the x direction options, and then here top story is headroom, and again this is plinth one, and bottom story is plinth level. Response reduction factor is 5 and zone factor is 0.16. Soil type is 2. Important factor is 1. Give OK. That's all. Next, to apply the wind load, what we have to do, we have to create some null type walls, because in the wind force is acting through wall, so we have to create a null wall and then we have to apply the wind load. So for that, let's select the elevation view. So the closed wall will come here in this grid, and then this grid, and here in front. So let's select a grid, apply OK. So here all over the wall will come. So we can add, go to wall or drawing wall option, and then here select property as none, and then you can just drag this one to draw walls. Next, let's choose the grid H. Go to elevation view, select H, give apply OK. So here also you have to add like this. It is done. Next, choose the grid number 3, apply OK. So you have to add like this. It is done. Next, grid number 1. Go to grid number 1, apply OK. Now if you go to 3D view, you can see this areas are covered all over the building. The areas are covered. So now we can apply the wind load. Before applying the wind load, let's see few basic important things. First, we need to find the basic wind speed, so that you can find it from Appendix A of IS 875 Part 3. So for Ahmedabad, it is 39 meter per second. And next, we need to find out all these three factors. K1 is probability factor or risk coefficient. K2 is terrain height and structure size factor. K3 is topography factor. So first, let's see that K1 factor. K1 factor is given in this table. So for 39 meter per second of wind speed, all general building and structures, we have K1 factor as 1. Next, let's see the K2 factor. K2 factor is this one, terrain height and structure size factor. So here it is given category 1 and category 2. So let's choose this category, open terrain with well scattered obstruction having height generally between 1.5 to 10 meter. So my category is 2. Next, let's see the topography factor. The topography factor value is given here. The effect of topography will be significant at site when the upward slope theta is greater than about 3 degree, and below that the value of K3 may be taken to be equal to 1. The value of K3 confined in the range of 1 to 1.36 for slope greater than 3 degree. A method of evaluating K3 values greater than 1 is given in Appendix C. So here our value is less than 3 only. So we need to consider K3 factor also 1. Now let's go to wind and then modify lateral load. Here choose this option, exposure from extensive diaphragm, and keep this windward coefficient and leeward coefficient as same, and wind speed is 39. meter per second. Terrain category is 2. Importance factor is 1. Risk coefficient K1 is 1 and topography factor is 1. Exposure height is headroom and the bottom is plinth level and give OK. Similarly, in the wind y direction also you have to change the same values 39 meter per second and these are all same. Choose plinth, give OK and then give OK. Next go to assign shell load uniform and here you have to choose the wind load in x direction. Next go to assign shell load wind pressure coefficient. So in the wind x direction first windward it is 0.8. So here this is the windward direction and this is the leeward direction. Similarly this is the windward direction and this is the leeward direction. So first let's go to this elevation view. Select this A grid. So this is our windward direction. We need to select this one. Apply OK. Next select the leeward direction that is H. Apply OK. Here go to assign shell load wind pressure coefficient. Leeward is 0.5. And again go to elevation view. Select the grid number 3. Give apply OK. Go to assign shell load wind pressure coefficient. In the y direction it is 0.8 windward way. Apply OK. Similarly go to elevation view. In the first grid go to assign shell load wind pressure coefficient leeward direction. Apply OK. So now we have assigned all the nodes. Before analysis let's assign the support condition. Go to base view, select all the columns and then go to assign joint. Click on restraints. Here you have to select this one fixed support. Give apply OK. Now if you check in 3D view you can come to know whether the fixed support has been assigned or not. The fixed support has been assigned for all the columns. Now let's define the diaphragm. Go to define diaphragms, add new diaphragm. Let's add diaphragms for each floor. I'm just giving the name as ground floor roof and next one is first floor roof and again second floor roof. Next headroom. Let's assign the diaphragms now. Go to shell diaphragm. Select ground floor roof, apply. Select all the ground floor slabs. Go to assign shells, diaphragm, ground floor roof, apply, OK. It is assigned. Next go to first floor roof. Select all the slabs. Go to assign shell, diaphragms, first floor roof, apply, OK. Next go to second floor roof. Select all the slabs. Assign shell, diaphragms, second floor roof, apply OK. And next one is headroom. Select this slab. Go to assign shell, diaphragms, headroom, apply OK. You check in 3D view you will come to know for all the floors diaphragm has been assigned now. Now let's check the model and start the analysis. Model has been checked. No warning messages were generated. So let's do with the analysis. Analysis is done. Next let's go for the design. Go to concrete frame design. Weave revise preferences. So here check the design code as IS 456-2000. OK. And then go to concrete frame design. Start design check. Now we have to check the members, concrete members, verify all members passed. So 9 concrete frames failed the design check. Do you want to select them? Yes, let's select that one and then right click show selected objects only. So these are all the overstressed columns. Since 9 columns has been overstressed, let's change the property, all the column property because we have given only very less dimension, less property of the column. So let's select this one and then change. So here I have selected all stories so that it will be modified in all the stories. And now let's click on this quick draw column option and then select the column property as 225 by 450. Now I have changed all the column properties. Let's check in the upper floor as well. See, everywhere it is updated. Now in the headroom level also the columns are there. So what you have to do here, select one story and then select all these columns whichever unwanted in headroom and then delete. Let's add 3D view and see. See here, whenever you are changing the column property, you have to be very careful because automatically the support conditions of the column will change, and again you need to make it as a fixed support. So for that, go to base, let it be one story, and then select all the columns. Go to assign, join, restraint, give fixed support. It is now changed into fixed support. Let's analyze the model and see whether all the columns are pausing or not. Go to design, again start design check. Now let's go to concrete frame design, verify all members passed. Now see, all concrete frame passed the design check. If you want to check the reinforcement percentage, go to concrete frame design and then design display info. Here rebar percentage you can select, give apply, OK. All the reinforcement percentage is shown here. You can check in this elevation view as well. Go to design, display design info, rebar percentage, apply OK. So you can see the reinforcement percentage for beams as well as column. In this way you can find out the reinforcement percentage. And next let's look into the bending moment diagram. So if you click on the bending moment diagram, you will be getting this window. Here you have to select moment 33, give apply, OK. So this is your bending moment diagram. And if you want to check the shear force diagram, you can just click on this shear force 22, give apply and OK. So in this way you can find out all the reinforcement details and moment, shear force, whatever you want, you can check it from Etabs. So friends, I hope you like this video. Please do comment in the comment box. Your comments are always welcome. If you like this video, hit the like button and also share it with your friends. If you feel this content is useful to you, please click the super thanks button below. You have to log in your email account, and then below this video you will be getting the button called super thanks. By clicking that button, you can pay some amount and support this channel for getting more videos. Thank you for watching.